Hello, in this video I'm going to solve the following problem for you. The problem is question number 2 from Mathematics 9709, Paper 1, Pure Mathematics 1, May, June 2023. Let us read the problem together first. Part 1. Find the first three terms in the expansion in ascending powers of x of 2 plus 3x to the fourth. It includes 2 points. The second part of the question, find the first three terms in the expansion in ascending powers of x again of 1 minus 2 times x to the fifth power. 2 points. And finally, the third part, hence find the coefficient of x squared in the expansion of this product. 2 points again. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do your calculations correctly, these are the answers that you will get. For the first part, 16, 96, and 216 times x squared are the first three terms of the first expansion. For part 2, 1 minus 10x and 40x squared are the first three terms of the second expansion. And finally, for part 3, you get the coefficient of x squared in that product is minus 104. Now, let us solve the problem together. Okay. For both of these cases, I will use Newton's binomial theorem, the formula in that theorem, which tells us that if a and b are any two real numbers, and if n is a natural number, so I'm using the symbol meaning belong to, yes? I have a plus b to the power of n is equal to sigma k goes from 0 to n is that n, and then I have n choose k, again this k is the counter, n is this number, and then I have a, which is this number, to the power of n minus k multiplied by b to the kth. So that's the formula that I'm going to use both for these parts. Okay, for the first part, if you compare this one with that one, for the first part, what do I have? A should be replaced with 2, or I would say that, okay, A is equal to 2, and B is equal to 3x, and N is equal to 4. So if I say what is 2 plus 3x to the fourth, then it becomes sigma, k goes from 0 up to n, but n in this problem is 4. And then I have n, which is 4, choose k, and then I have a to the power of n minus k. A is 2, n is 4, k is just a counter, and multiplied by b to the power of k. b is 3x, the total expression, to the power of k, which is the counter. So this is the form that I have. Now, of course, if I choose k to be 0 and plug it here, it gives me the first term. And if I put k equals to 1, it gives me the second term. And if I put k equals to 2, it gives me the third term. And that is exactly in the ascending order, because you see that the power k appears here. And this is only term involving x. So when I put 0, I will have the 0th power of x. If I put 1, I will have the first power, and if I put 2, I will have the second power. So in the way that I have written it here, automatically it takes care about the powers in ascending order. Okay, so I would say the first term is what? The first term is equal to, replace k with 0. This becomes 2 to the power, and then this becomes 3k to the power of 0. But 4 choose 0 is 1, 2 to power 4 is 16, and this is just 1. So that becomes 16. That is my first term. My second term, what is that? My second term is equal to 4 choose 1, I have to replace k with 1. Be careful. Second term, k is 1. Okay? And then I have 2 to the power of k is 1, so this becomes to the third. And then I have 3x to the power of k, but k is 1. Okay, 4 choose 1 is just 4, so it becomes 4. Multiplied by that is 8, and multiplied 3x. So 4 times 8 is 32. 32 times 3 is 96x. So that's my second term. And now for the third term, what happens? I have to choose k to be 2. When I choose 2, then I will have 4 choose 2. I will have 2 to the power of 4 minus 2, which is 2 to the power of 2. And then I will have 3x to the power of k, but k is 2. Okay, so let us try to calculate this. For calculating this, I will use this formula. N choose k is equal to n factorial divided by k factorial, the difference between them factorial. Okay, so 4 choose 2 is 4 factorial, k factorial, which is 2 factorial, and the difference between them, which again is 2 factorial. 2 to the power of 2 is 4, and 3 to the power of 2 is 9. X to power 2 is x squared. And I have to simplify this, but you know 2 factorial is 2, 2 factorial is 2, so 2 times 2, 4, this 4 and the whole thing is gone. And 4 factorial is 1 times 2 times 3 times 4, which becomes 24. And 24 times 9 becomes 216 x squared. So that is my third term. So if I want to write the terms in order, what was my first term? It was 16, and then the second one was 96x, and the third one is 216x squared. To see things a little bit ahead of us, it means that if I expand this, okay, let us visualize it in that way. If I expand this expression, the first expression that I will get is, the first term is 16, the next one is 96x plus x, and then I have 216x squared. And of course, you know that if the power is 4, I have 5 terms. So I will have 2 more terms here, which I don't need to calculate, okay? So let us keep it like this. And I will do similar calculation for the second one. But in the second one, what is happening? If I want to do the second one, here, 1 is playing the role of A, and minus 2x is playing the role of B, and of course 5 is playing the role of N. So if I want to write the second one, what should I write? I would say that in this problem A is 1, B is negative 2x, and N is 5. And then I replace these here in that formula. So I will have a 1 minus 2x to the 5th is equal to sigma. I can use the same counter from 0 up to n, which in this problem is 5. And then I have n choose k, in this case 5 choose k. And then I will have the first term, which is 1, to the power, as you see here, n minus k, but n is 5, so it becomes 5 minus k. And then I will have b, but b is negative 2x, be careful about that point, to the power of k. Okay? But you see immediately that 1 to any power is just 1, so I can simplify it a little bit more. So this becomes sigma. K goes to 0 to 5, and then I have 5 choose k, and then minus 2 to power k, and x to power k. So this is what I get. So again, I want to have the first term. It means that I replace k with 0. Okay? So this becomes 5 choose 0. minus 2 to power 0, x to power 0. This is 1, this is 1, this is also 1. So this becomes 1. The second term is 5, 1. So when I say second term, I put k1, and then it is 5, choose 1 times minus 2 to power 1, but x to power 1 as well. But 5 choose 1 is 5. I have 5 students. I want to choose one of them. In how many ways I can do that? I can do it in 5 different ways. And then I have minus 2 and x. So it becomes minus 10x. And finally, the third term is equal to 5 choose 2 minus 2 to the power of 2 x to the power of 2. I replaced every x with 2. 5 choose 2, we can calculate it using the formula that you see here on the board. So it becomes 5 factorial over 2 factorial, the difference between them, which is 3 factorial. And minus 2 to power 2 is positive 4x squared. And here I can simplify it further. Instead of 5 factorial, I write 5 times 4 times 3 factorial divided by 2 factorial, which is 2, multiplied by 3 factorial. I don't need to open it up because it is going to be cancelled. And then I have 4x squared. And if I do these calculations, so this and that are gone. 5 times 4 is 20, divided by 2, 10, multiply here, it becomes 40x squared. Okay? Okay, so now, what is the result if I want to write it something similar? So the first term in this problem was 1, the second term was minus 10x, and the third term is 40x squared. What does it mean? It means that if I am patient enough and to expand this, I will get this as my first term, I will get this as my second term, and I will get this as my third term. And of course, what I know that because this is 5, there will be 6 terms involved, so I will have 3 more terms, okay? Which I don't need to calculate. I'm just looking a little bit ahead for the third part. But one thing is important, because this is the second power of x, the next one, the power will be increased by 1 unit. So here x3 is involved, here x to the 4th is involved, and here x to the 5th is involved. Yes? Okay. And it's the same story here. So here it's x squared, the next one is involved with x to the 3, and then the next one x to the power of 4. Now the third part of the question is that when I multiply that expression by that expression, okay, what will be the coefficient of x squared? So that is the reason actually I wrote these two. If you want to understand that, so if you don't mind, be patient and let us write it down here. So this becomes 1696x and then plus 216x squared plus one term here, okay, one term here. I don't know these terms, but I know that the power of x here is the third power, here is the fourth power. And then I multiply it by what I got there, 1 minus 10x plus 40x squared, and then again plus some question marks. I don't know the details there, but you will see that they are not relevant to this problem. Why? Because imagine that you multiply this polynomial by that polynomial. Here you have 5 terms, here you have 6 terms, so in total you will get 30 terms, okay? And then you have to simplify them. But you're only interested in the term whose x appears with the second power. Okay, how can I make the second power? So is there any way that when I multiply 16 there, it gives me a second power? Yes. 16 multiplied by 1 will not give me the second power of x. 16 multiplied by that will not give me a power of x squared, but 16 times that will give me a power of x squared. Just consider that. So 16 times 4 is 64, so it becomes 640 x squared. So I will get an x squared term by multiplying 16 by that. But the important thing is that I don't need to continue because the powers of x here are more than 2. When I multiply them by 16, the power will be more than 2. Okay? So that's the only one. I took this into consideration. Let us go to the next one. I multiply this one here, it will not give me the second power. This multiplied by that will give me a second power, which becomes minus 960 x squared. But there is no other x squared coming in where I'm multiplying this by any of them, because this will give me the higher powers of x. So it is hopeless. If I want to find x squared, there is no need to continue. Okay, let us go to this next term. Is there any hope that I can get the second squared, the second power of x? Yes, by multiplying this here. Okay, so it gives me plus 216 x squared. Is there any other way that I can construct x squared by this term? No. Yes? Okay, can I consider higher powers? Not at all, because these powers of x are at least 3. So when I multiply it even from the minimum one, from the term with minimum power of x, I will construct a power more than 2 for x. So there is no point of adding them. So these are the only terms involved with x squared if I start multiplying. But of course, when I multiply and I get similar terms, I will simplify. So this means that I have to write 640 minus 960 plus 216 x squared. And if I ask you what this is, it's a simple calculation. You get minus 104 x squared. But the question is asking you about the coefficient. So the coefficient is minus 104. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.